नमस्ते बच्चों, हमेशा खुश हो। माई सेल्फ JVN Dr. Monica Trivedi, Faculty of Education Methodology, and today's topic is a phase equilibrium. So in a phase equilibrium we have to learn about the phase, what is a phase, what are the components, and what is the degree of freedom. Then after the phase rule, what is the phase rule, how to draw the phase diagram for different component like a water, sulfur. Okay, the phase diagram of a two component system and the congruent melting point. So these are some points which we have to discuss in this topic, which is a phase equilibrium. So first we have to know about what are the component, what are the phases. As you know that matter has a three phase: solid, liquid and gas, and these three phases are present in a different components, like for example water. So for water the phases is liquid, solid and gas. Okay, and the component for this particular is the water is H2O. So for a water the phases are three and the component is one, which is H2O, because it's represented by the H2O formula. Okay, the chemical formula which is used for the water is H2O. So it is the H2O is a single component, and phases are three: liquid, solid and gas or vapor. Okay, so now here you can see the component. The smallest number of independently variable constituent by means of which the composing of each phase can be expressed in a chemical equation. Okay, and for example in a water system the chemical component of all the three phases is H2O, and therefore it has a one component which is H2O. So you can see here the ice represented as H2O solid, and the water H2O represented as a liquid, and the vapor H2O represented as a gas. Okay, so next is the degree of freedom. What is the degree of freedom? So it is defined as the minimum number of independent variable factors such a temperature, pressure and a concentration of a phase, which must be fixed in order to define the condition of a system completely. A system having 1, 2, 3 or 0 degree of freedom, it is called univalent for a 1 degree of system. For 2 degree of system it will call bivariant. For 3 degree of system it is called trivariant, and for 0 degree of system it will call non-variant system. Okay, for example the water system, the H2O solid and H2O liquid and H2O gas are coexist at a triple point. Okay, so for this type of system, the degree of freedom, if we calculate the degree of freedom, the all three phases can be in a equilibrium only at the particular temperature and a pressure. Therefore, when all three phases are present in equilibrium, then no condition need to be specified. The system is therefore zero variant. In the in or it can also say the invariant, or it has a no degree of freedom. Okay, so the next topic is a phase rule and a phase diagram of a water system. So what is a phase rule? First we have to learn about the what is a phase rule. So the phase rule is stated that if the equilibrium between any number of phases is not influenced by the gravity or electrically or a magnetic force or a surface action, but are influenced only by the temperature, pressure and concentration, then the number of degree of freedom f of the system is related to the number of component, which is denoted as a C, and the number of phases denoted as a P. By therefore the phase rule is f is equals to degree of freedom is equals to C minus P plus 2. Okay, the C is component, the P is phases, and plus 2 for a phase rule. So first example for the phase rule is a one component system of a water. Here you can see the pressure and temperature diagram of a water system. In this diagram, the fusion curve, the vapor curve, and sublimation curve, three curves are present, and we have three areas: the liquid, solid, and a vapor, and one triple point. These are this will be the point which we will discuss in a phase diagram of a one component system. Okay, and this is the simple phase diagram for a one component system for a water system. So, for a phase diagram of a water system, the first curve, we have to discuss the curve, the degree of freedom at a curve, degree of freedom at a areas, degree of freedom at a triple point, and degree of freedom at a metastable condition. Okay, so for this diagram, there is three curves OA, OB, and OC. In this diagram, you can see the curve OA, OB, and OC. Okay, the next is the areas. You can see the areas for the ice, for the liquid, and for the vapor in this diagram. And the third one is a triple point. The triple point is denoted by the O, and where the all three phases are coexist. And the last one is a metastable condition. For the metastable condition, the curve OA dash will represented as a metastable condition. This is a super cooled condition of water, but it is not very much stable condition. Okay, so for the if we calculate the degree of freedom for all curve, for all curve there is a one component, because the H2 will be represented as a liquid, gas, or solid. So the component is one. For each curve there is a two phases are coexist, like liquid and gas and solid, and solid and gas. So for each curve there is a two phases coexist. So you have to put 2 for a phase plus 2. If we calculate this, you will get 1. So each curve of this phase diagram have a degree of freedom 1. So as well the system is a univariant. Okay, for curve OB you will get the 1 degree of freedom, or for curve OC you will get the degree of freedom 1. Now at the triple point, if you calculate the triple point, there is a three phases which coexist in a at a triple point. Okay, and the degree of freedom you will calculate, it will be 0. So the system is a non-variant, or a 0. Okay, so now the curve OA dash, and it will also known as a vaporizing curve of a super cool water or a metastable equilibrium, where the super cool water and a vapor coexist. Sometime water can be cooled below 0 degrees centigrade without the formation of ice. This water is called the super cool water. Super cooled water is unstable, and it can be converted into solid by slight disturbance. Okay, so for this, if you calculate the degree of freedom for the compound is 1, the phase is 1, which is a liquid, and the water, liquid, and ice represented by this diagram, and the degree of freedom will be 2, because 1 is cancelled by the 1, and you will get the 2 for this kind of a metastable system. Okay, so this is all about the one component system of a water. Thank you.